All right, guys. So I'm gonna unfreeze the screen right now, and this is all I want you to do. I want you to draw. This is a function of e to the x. I want you to draw on the whiteboard just like a rough sketch of what the derivative graph would look like. What is the graph of the derivative, or of this function's derivative function? What would it look like? Okay. So why don't we take about 3 or 4 minutes to try that with a partner, and then find a space on the whiteboard and do that. Okay. What should the graph of the derivative function of this function look like? Okay. All right. So go ahead and find a space and try to figure it out. Okay. I want to see what you guys end up getting. Try your best. That's
Yeah, I think it's now the section stuff.
Derivative of that, and I don't know what it is. E to the x. Maybe that could be like x to the x.
That's what the section said. I'm just like stupid.
X e to the x.
We want a section. You will pay. Oh gosh.
Did you guys figure it out? No? You guys see one attempt? Okay. See if Josh can maybe come in and help us out here. We're trying to draw the derivative function for this function here. Do you think you have an idea of this one? This is the function, or can you graph the function, the derivative function for this function here? All right. Don't worry about it. Okay. All right, everybody give up? Okay. We're going to go over first what the derivative first is, and then I'll kind of show you a proof of this. If you guys, I'm going to start off with the proof today. You guys ready? Okay, so let's get out your notes. This is going to be one section we're going to go over today. That's it. It's really not much today. Well, I wouldn't say that. Sorry about that. It's enough for a whole class session, but go ahead and write this down. So 4-4 derivatives of exponential and logarithmic functions. So Deja has an excuse. I remember she has like regionals or something like that. But she did ask me if we had to go over exponentials and logarithmic functions about like a week ago. And I said, maybe not, possibly not. And it turns out this was the next section. So I feel really bad. So yeah, I'll send her this. She has a valid excuse, so she can get this. So Deja, if you're hearing me, sorry. What is interesting about this derivative? What do you guys notice about the derivative function for this function of e to the x? Does anybody remember what e stands for? Like, what is e? Yeah?
It's a constant. It's like 2 point something something something.
Yeah, and it has to do with what's called a natural base. And I guess you're gonna kind of see why this is special, and it's not just an arbitrary number. But what's interesting about this, the derivative e to the x is what? E to the x. So what it's telling me is, or what is it telling me? Yeah, what is it telling me? What should the derivative function for this function graph be? What should it look like? The exact same thing. And that's what makes it, or I think that's what makes it a natural base, that 2.7 number, because at this number, and we give it a variable exponent, if you take the slope at every individual point, the slope is itself. So that's what's insane about this, okay? It's not a coincidence. There's a lot of other mathematical inferences that you can make from this, but that's generally the big one, right? And I think even your textbook or some other textbook I read said that. And it was well before, so it was a different textbook. It was well before calculus. I remember reading like, I think a pre-calc book where it said the slope at every point of this graph is itself. And I'm like, I don't think that the kids in pre-calc are going to understand that quite yet. But now you're at the level where you can. Okay, you can clearly see that. Okay, so let's go over the proof about why that is. So you don't have to write this part here. These are just notes to myself. But you generally want to write this down. So this is one of the few mathematical proofs that I think is valuable to kind of go over. Like, why is the derivative of e to the x equal to e to the x? That's very interesting. So we go back to this notation. The derivative e to the x with respect to the variable x is equal to, we're going to go back to the original definition of what a derivative is. It's the limit as h approaches 0 between which is essentially the gap between e, like a y point of e x plus h minus e to the x over the h gap. Okay. Again, as that gap shortens down to 0. And then, if you remember your rules for exponents, if you have a base with two, like a, not like distinct in this case, but normally you can kind of separate them. If you have two exponents that are being added together, it is essentially saying the same thing as the same base multiplied to one of the exponents times the same base multiplied to, or to the other exponent, e to the x times e to the h. And then this still remains, minus e to the x, all over h still. The next step is the limit as h approaches 0. You can actually use, or you can kind of factor out e to the x out of both this product here, which I haven't worked out. I just left it like this. And you can actually factor out a common factor in e to the x. And what you're left with is e to the x times e to the h minus 1. Does that make sense? The next part, though, okay, so go ahead and write this down. But the next part does require us to kind of look at your book in order for you to at least justify this next step. What I'm going to do now is I'm going to separate e to the x outside of this terminology, this limit. Because really, we're only looking at the limit in terms of h and what it's approaching. So you can pull out e to the x on the outside of the limit. Very rare move, that is, a mathematical move that we just made there, but that is possible. But especially for the context of this proof, it is useful, but it's not always useful to do that. So don't be confused. It's not a very, very common mathematical procedure or just math that you see on a regular basis. But you're left with this. The limit as h approaches 0, and you have e to the h minus 1 over h, okay? I wrote a note to myself that it's at the top of page 180, okay? And you don't have to write this note, right? Actually, I can't refer back to what I was writing to myself, okay? Oh, okay, yeah, that kind of makes sense. You'll see. You can just write down top of page 180 what this is going to equal to. You guys ready for this? You guys ready for me to switch gears to the book so I can show you what I'm talking about? This is at the page, not the top, but this is more to the side of page 180. What you're looking at is the graph for this. Danny? Here. It's okay. Well, at least you're here. That's fine. So you have the graph and the table support this conclusion. Essentially this. So if you look at this here, and you're looking at the limit of as h approaches 0, what does it seem like the limit is approaching? Yeah. So essentially that limit there is equal to 1. So that's why this next step is a bit of a leap, because this next step leaves me with, if this is equal to 1, I essentially have e to the x times 1, which leaves me with what? E to the x. So in conclusion, that proves to me that the derivative is literally e to the x. Okay. This, I think, is the better version, however. The better version to take in. Because what if your exponent is in itself another function that you can derive? So that, in that way, I say this is the better version. They're both the same, but it's saying that in place of x, what if that exponent is not just x, but it's some kind of, like function in itself that you can derive. So it says that the derivative of e to the u is equal to e to the u itself, but this time we apply the chain rule. We also take the derivative of whatever that guy is here. Technically, you do it here, e to the x, and you take the derivative of x. What is the derivative of x? What is the derivative of function of x? Just 1. So technically, this is e to the x times du of dx, and du of dx is just 1. Okay, so I'm getting ahead of myself. I want you to work on this problem right here. This is the example problem that you may write down, but I want you and a partner to work on this. Not quickly, but with a little bit of time to figure out what's going on, okay? So find out the derivative of y, the derivative of this function, okay? And then just show me what you get, what you end up getting, okay? Yes.
Can you go expert to the top?
Sure.
Because, no, I know. But I thought that was a 4. Is that even the e to that e to the 4th?
Yeah.
Go to the right. Oh, you. Okay.
Sorry.
What is that?
Don't make fun of my writing. It's good writing, folks. Does that make it any more like you? No, it does not. All right, it's just a weird looking you.
No, it looks like you. I just see it.
You got
What? You
it's there now.
Is that x plus?
The actual, do you want us to simplify further than just?
Nope. You can leave it. Yeah, you can leave it. Yeah, and it's unsimplified
X
version.
squared?
Huh? That's squared. That's x squared. X squared. Oh, that would be pretty evil to give you a y in there. I'm sorry, but it is. That is an x squared. I'm sorry. That is an x squared. Let me write that a little bit more clearly.
Wait, ours.
It just didn't because it's not that hard. It's just kind
But yeah, it's here.
Okay.
You just have to add equation. Like e to the u.
Anybody have plans for this weekend or the next weekend for Thanksgiving? Nice. Okay. Oh, I'm sorry to hear that. That means you guys are working really hard. Any plans?
Doing homework because next week is turning.
I'm sorry about that. Yeah. You guys are very diligent, actually. I give you a lot of credit. There are times where I'm at night, I'm like, I'm not going to do this. I'm like, I'm a bad student. I'm not doing well myself. Jeez.
Do you have any plans this week?
You know what? Sleep is not an issue. Not that I get like a lot, but like I'm okay now. I'm like I just took it. Like all right, this is my life. No, I'm just kidding. I get a decent amount of sleep now. I get it varies. Some nights I'll be like up and I'll have like maybe 2 to 3, 4, and then some nights I'll just like crash and have like 8 to 9. Be like, what happened? My lesson plan. I don't have one. I gotta make it. Let's go. So I'll be camping this weekend. That's what I'm gonna do. So yeah, we're gonna go to Idlewild.
I've been there.
Have you?
Yeah.
Is it really nice?
It was pretty nice.
Yeah.
It was like 3 years ago though.
Oh really?
I was at like an actual camp, so I wasn't at like a campground. Is that what you're doing?
I have no idea. I don't know. I'm just being led.
Okay.
I'm gonna show up and just like, I guess this is where we live for the next 2
We're
days.
in the winter, so it was really nice. We got a bunch of snow.
Really?
Oh really?
I don't think I want snow though.
Well, I
Especially we cannot handle.
Well,
Uh,
just by leaving in San Diego,
oh yeah.
it's kind of nice to just have a little bit of diversity. But
Oh, I got you. Yeah, I guess so.
It's
I don't
nice
know.
to have snow once in a while. Like if you actually lived in snow, you probably wouldn't like it or appreciate it as much.
Oh, if you lived in snow, you
Like-
won't appreciate
Like,
it.
if you
Oh, I
lived
see what
in
you're
somewhere
saying.
where it's
Yeah,
like
snow.
north or east.
I got you. And then like
Yeah,
yeah,
my brother is.
huh? Your brother? Oh, that's what your brother's in right now, or he's currently in it right now.
Well, it's not snowing yet, but he's in New Hampshire for college.
Okay. Oh, you must miss him. I miss him. I'd be like, big bro.
Yeah. He's coming back for Christmas, though.
That's cool. Yeah, just keep him here. Yeah, kidnap him technically. Yeah.
No, because it's only 1 week, so. They're gonna go to Connecticut to spend Thanksgiving with his wife's family.
That sounds really nice. All right, guys. Here's the solution. It's actually in your book. Okay. So if you need to write down the reference for this, it's going to be page 80 at the bottom. It's the first example, actually, but I thought it was a pretty good way to start. There it is. You can keep it in this form. It's just e to the x plus x squared times the derivative of the inside function, which is 1 plus 2x.
They just left it.
So who? All right. So I give up. Oh, I'm sorry about that.
I was gonna do it over, so what are you gonna do?
Okay. So I think the best thing to define first is a u. What is your u in this case? You can look at the solutions too to extrapolate it, but sometimes it's a little bit easier to understand it yourself. What is the u in this case? Yes. X plus x squared. So the derivative of this outside function or this big function is just itself, e to the power of x plus x squared. Okay, and then you take the derivative of u, which what is the derivative of x plus x squared? I think yeah, it's just 1 plus 2x. Okay, so in this case, it's just e to the x plus x squared times that derivative of the inside function. Okay. And that is the solution for this problem, right? Not too bad. I think you guys are doing great. Here is the next one. There is a proof for this, but I don't want to go over it only because I think for the interest of time, it's not going to help. Like, it's not going to be as beneficial as going over other content, but I do have a proof right underneath this. But it's essentially this, as long as, so this is the derivative of a base to the power of any base to the power of x, not just e to the x, okay? Things are a little different when you're talking about a base that is not e, right? So every other base that is not e and is positive, okay? The rules change again if it's going to be a negative base, but if as long as it's positive, does not equal 1, okay? And also is not e, so also put that a cannot be e. You can write that down too. That's another additional fact. The derivative, I'm going to write this in the more robust comprehensive form, is a to the u is equal to, again, itself, a to the u times the ln of a. And then this is just here for the chain rule. If you had an inside or you had a function that could be derived in the place of u, then you're going to take the chain rule and you're going to take the derivative of that inside function. Yes, Aaron.
So in calculus, I've seen some people write natural logs as simply just like log, since they don't really use any other type of logs in calculus. Is it okay to just write natural logs
Well,
class as log, or
what natural log is a log, but specifically with the
power of
base.
e, right? But
If you write it like that, that's fine. But you have to, because if you don't, I believe that infers that the base is 10.
yeah, it's
Yeah.
just I don't know. I've seen some people in calculus just use just simple log and mean natural log, just because
Really?
there are no other uses of log other than natural log in calculus.
I see what you're saying. Yeah, I guess so. I would rather you be I'm going to be a little bit more rigorous and say that you have to be very specific. Even though, yeah, most of the application is inferred in, or most of the applications in calculus are probably just going to use the natural base. I still want you to specify, because if you're going to be outside the context of calculus and you have that habit, it's not going to make it very easy for other people to follow. Like, what's going on? Okay, so a little bit, I think, more comprehensive and safe if we specify that it is natural log. So good question, though. Good question. Okay, does everybody have this down? Do you think you can apply this now? It's almost a plug and chug now. By the way, I gave you a cheat sheet for Pythagorean identities. So one student came last week, and I had a hard time identifying my Pythagorean identities. I really haven't retained all of these to commit to memory and heart. So I want to give you this at least for the homework. I think I actually went over the questions on the exam that day when the student came. Okay, just briefly, because I don't, unless you're it's like some other students that have a very good photographic memory, I do go over the test with you just briefly because I don't think you're gonna commit it to picture-esque memory. So these, like any of the tougher Pythagorean identities, will not show up on the exam, nor shall it show up on the AP exam. Like really really tough ones, I think, like this would be tan of x plus or minus y is equal to tan x of plus or minus tan y over 1 and so forth. I think that's
I'm seeing it in front of me. I don't even understand.
yeah.
I'm looking at it. I don't understand.
I mean, these applications might come in calculus 2 or 3, but you don't need them, at least in the context of calculus 1, at least what they want you to be at, the level they want you to be at. I mean, ideally, you should be at this level, but I'll be honest, I'm not quite this level myself, and I'm the educator for this, right? All right, here's your challenge problem, okay? So you have this, everyone has this written down, correct? Yes? I will give you a challenge problem now. To understand in itself. All right. Okay. I don't think any of you guys take your calculus books. Oh no, that's really bad. Okay.
I brought mine.
This might help as a
Can I pull it
reference.
out?
Huh? No. Okay. At what point xy on a graph of the function? Dang it! I completely left out the actual function itself. This is a trick. This is a trickery here. Okay, yeah, I said the example. They tried this one. Okay, so I don't know. It's just kind of weird for you guys to read my own little notes. I guess it's trivial anyway. Okay, this example is at what point xy on a graph of the function y is equal to 2 to the x minus 3 does the tangent line have a slope of 21? Okay, so knowing what you have to do to take the derivative of any base to the exponent of x, okay, knowing that, can you answer this question? Okay, so again,
yes, no.
Huh? No. At what point? At what point? I'm sorry.
Okay.
The way I phrase that is a yes or no question, but the question itself that I'm posing is not a yes or no question. Okay. All right, guys. Try to get to work on this one. I don't know what to do. Okay. At what point xy on the graph of the function y is equal to 2 to the x minus 3 does the tangent line have a slope of 21? So what does tangent mean? Does anybody remember what tangent means in this? Okay, perpendicular and or just at one point, right? Or I'm sorry, it's not at one point. It's a slope or tangent at one. I'm sorry. When I say tangent line has a slope, okay, of 21. Hold on, at what point? Let me see what I just wrote. Okay, there's this function. There's a tangent line. At what point is the tangent line? Okay, so I'm asking at what point do you find like the derivative is equal to 21? So think about it. You are given the function y is equal to 2 to the x minus 3, but it's asking you at what point xy do you have the derivative at 21? So the derivative is 21, and then I have the function to find the derivative function. So you can set things equal to each other. The derivative of that function is equal to 21, maybe. Okay, maybe that'll help. Then from there, you can kind of solve for x. Give you a few minutes to do that, and then I'm going to ask you what you did. I'm going to ask for any suggestions or help. Is it too hot or muggy in here, guys? It's cold. Okay. Does that mean you want the heater up a little bit, just like a degree higher?
Well, yeah, I don't care.
I think we're okay. We'll just leave it at that. That's a lukewarm response. It's not like overwhelming. Yes, it's so cold in here, Mr. Wee. I don't like it. Okay. Anybody need more time? Do you want me to go over this?
Don't you keep this and then you times that?
Y
And
with
then
x
it would be
equals 0 and then
is it
b,
just the
but
2 or what? I don't know if I did this.
No, I think you take the derivative separately. You take the derivative of this, and then you take the derivative of this. This just kind of cancels. You don't need this.
But if it's the same
That's here. So just taking the derivative of that.
Oh.
We're taking the derivative.
Yes.
So in this case, this is this.
Yeah.
So,
So it says that the
becomes
derivative
2 to
of
the
that
x.
equals just that times the natural log.
Yes.
So that means this part we don't have.
Yeah, we don't. So yeah, the 3 is canceled. Well,
So
canceled.
it's just 2 to the x times the natural log,
Yes.
and then is that
It's 2x.
All right.
give that just the x.
No, I think it's just x.
All right, guys.
And
So
then, I guess 7 equals 21.
I see this one is pretty troubling. Now, this I would say is a very common type of problem that they'll ask you for just to see where you're at in AP calculus. This is definitely going to be an AP problem, I would say. If I were making the AP exam, I would give you something like this here. At what point? So it's asking me at what point x, y on the graph of the function. So if I had to look at the graph of the function, here's 2x minus 3. At what point does the tangent line have a slope of 21? What it's asking me is at what point do you think the derivative or the slope at just one of these points, that slope is going to be 21? Do you see what I'm saying? So, yeah. Like, what would you say the slope at this point is right here, Nathan? Okay, how about right here? How about here? Like 2 or 1? How about here? How about here? But it's getting higher and higher, right? At what point is the exact slope going to be 21? That's what I'm asking you. The tangent line. So the tangent line just means like this line that you draw through that only touches that point, and that point right there, or that tangent line, as long as it's touching it, only at that point will give you the slope. Okay. But what I'm essentially asking for is the derivative. That's what the derivative is. It's just that slope at that one point. Okay. So when you see tangent, when you see this here, the tangent line, that's interchangeable with just asking where is it, or a tangent line that has a slope of 21. If you have a tangent line of that has a slope, I'm basically asking you what's the derivative. Where is the derivative at 21? Okay, so let's look over here, and here is my original function. Oh, 2x minus 3. Okay, so I have the formula to find the derivative of anything that looks like it has a base that is not, or that's greater than 0, that's not 1, and is also not e. And I have the general formula here. What do you suggest I do? Anybody have any suggestions for what to do with this function here?
Yes. Yeah.
L. Oh, so you're telling me to take the derivative, yes, of this, right? Okay. Okay, so it would be what? What are we saying it is here? And if you look at it this way, guys, this function here, it has two separate parts. So you can take the derivative of 2 to the x, and you can take the derivative of -3 or -3. What is -3 is going to, what is the derivative that's going to? Just 0. So we don't really need to know. At the end, it's going to be like I'm going to leave space. I'm going to say, it's plus 0. That represents the derivative of the -3 part, okay? But for this here, what does it specify that I do next? What is the formula for this derivative? What do I do? So I'm taking the derivative of 2 to the x. So what should it look like? The derivative of 2 to the x.
First, just write 2 to the x.
You're absolutely right, guys. 2 to the x. And now what's the next part going to look like? Yes, the base. That's right. And what is the derivative of the inside function? So the derivative of u. So it looks like our u is x. What is the derivative of x? 2x. Or I'm sorry, just x. So technically it is 1 plus 0. So that's it. So it'd be dy is equal to dx is equal to 2 to the x times ln of 2. I know that's confusing what I just did, but if you saw like x squared, then you would write times 2x. Does that make sense? That'd be the chain rule. That's right. This represents the chain rule. Anytime you see u's and du's and stuff, that's basically telling you chain rule, okay? Don't ever forget the chain rule. That's all it's telling you. Are we done? Is this question asking us for the derivative function? It's asking us for a point, okay? So we know the derivative is 21. I don't know. So what do I do now? Any suggestions for what I do now? How can I set this up to figure this out? Come on, Allie, did you have some? Okay, yeah. No, yeah.
I think you can make it equal to 21.
Okay, so what you're going to do is they give you one fact. They say when the derivative is 21, what is your x and y value? What is your x and y coordinate? Well, if I set this equal to 2x times ln of 2, oh, whoops, ln of 2, not an exponent, but that's a whole number, okay? Sorry. Okay, again, that's not it. Basically, what can I end up solving for? I can solve for the x, right? Nice. Okay. Any suggestions now on how to do this?
So,
Hold on, Nathan. What did you say?
so you replace dy and dx because like that is
Do you have like
Because so you found the derivative function, right? Any x you put into like any x coordinate or x point you put in there, you will find the derivative at that point.
alright.
But you're going backwards because they said at what point are you going to find the slope of 21, the derivative at 21. So again, this function that we just came up with is a derivative function. That means that I could figure out the derivative or the slope of the tangent line at any x point. You pick. But this time, the question is not asking for that. It's not asking what's the derivative going to be at when x is equal to 2 or 3. It's asking the opposite. What if your derivative was 21? What is your xy coordinate going to be?
But wouldn't we have to like have a reciprocal of it? 21. Wait, was the slope of 21 like the original?
So this is what you're thinking right now. So I think when you're saying reciprocal, what this means is this. I have a function, right? Squigglies, right there. And I say at some point the derivative, the tangent line, okay, the slope is going to be equal to 21. I'm just trying to find that point. The thing that you're talking about, the negative reciprocal, is this. What if I needed to find the equation of the line that is perpendicular to that? Then I start doing the negative reciprocal. Yeah, so all I need to do is just find, when I ask for the tangent line, all it's inferring is I just need to find the derivative at that point. The slope of that tangent line is equal to the derivative. Yeah, sorry.
We're just trying to find the slope, or we're trying to find the line?
Not even the line.
The point.
Just the point.
Oh, to the point.
Do you have an extra calculator?
Yes, I do.
Oh, that's right.
Well, did you say just right there?
There's one here.
This isn't a good one. Sorry.
Is it like the TI-1?
No, it's a TI 89. TI 1. You gotta
One.
you got hand cranking, you know, to get the power. Okay. That's part of your room, you said?
Yep. So,
Okay, so now you have 21 divided by ln of 2 is equal to 2x.
oh, can you just have the log base 2 here?
Okay,
Wait, can I see that?
so that's where we are right now.
Yeah.
Oh, yeah.
In order to cancel the 2 to the x. Do log base 2.
So let's see.
Oh, I did it different.
All right.
I just took the logs and brought the x.
So everybody got that down so far? Everybody, yes?
You can do log to get the x. But that's or no, do it with e.
Well,
And then log base.
yes, log base e, but all right, so this is going to require us to kind of think back to so let's see. Let me go back here really quick. All right, it's going to go back to a little bit of review from pre-calculus. Are you guys ready for this? So don't worry, it's stuff that we should know, okay? But yeah, we should know a lot, not just you, Nathan. We should know a lot, but I'm a little rusty myself, okay?
Could we do log base 2 on both sides? That is an option, right?
Log base 2
2
on both sides. Oh, to multiply to both sides? What are you asking me to?
Take a log base 2 of sort of both sides of the
Just to
equation
get
or
rid
to
of
get
the
rid of the 2.
2x.
I believe so. What did your final answer come out to then?
I haven't gotten it yet.
My final answer is 4.92.
Okay, so not quite with. Oh yeah. You're good. You're fine. You're fine.
But you don't know that.
So you can do 2 options. Okay, you can do 2 options. You can do log base 2 on both sides of this to get rid of the 2 here.
Isn't that just like log 10 over log 2? Same thing as log 2.
Okay, and you can plug that into your calculator. Are you ready to take the exam? Yeah. All right, go ahead and have a seat.
Yeah, see that was my strategy.
So yeah, this is fine. It's a little bit harder to do a calculator command for. I'll show you the other method that you can do in blue.
I think the yellow calculators that are provided can do just a log base 2.
It can. Oh, just log base 2, but then you can't manipulate the base though, correct?
No, you can't.
Oh, you
Yeah,
can.
or yeah, you can manipulate the base of whatever number you want.
Okay, so let's go ahead and do that. All right, if you have a graphing calculator, please get it out.
Log base 2.
All right, Aaron, so how did you find log base 2 or log base anything in here?
They have it on the TI-84. I don't know if they have it on
Want to borrow
the
mine?
Well, let's just see on the 83 if I can
Okay,
find
so
it.
I went to math
Uh-huh.
and then like closer to the bottom of the thing.
Okay, so you
But
went.
It looks like it might not have it on this.
All right.
It doesn't look like it.
Does anybody in here have an 83? Okay, everyone's using an 84. Okay, so can I borrow someone's 84 right now? All right, thank you, Nathan. Don't worry. I got Nathan, and then Christina, you just okay. Thank you very much. You're gonna go to math, and then what'd you say at the bottom? Oh, wow, that's very nice. Is that it right there, Aaron?
Yep.
Log base?
You click on it and you can just plug it in whatever.
Oh, that's magnifico. Log base 2 of, and then you're gonna put let's
21 over natural log 2.
see, what is it? Natural log, which should be where
It's somewhere on the side.
right there. 2. Look how old I am. I'm just kidding.
Another parenthesis there.
Oh, nope.
Yeah, you need another.
Oh, sorry, because there's already a. Yeah, I think we're good. Okay, so that's what you guys should end up getting. Now, emergency situation. Okay, here's an emergency situation. You might want to know the other technique. Thank you very much, Nathan. Did you get that, Nathan? Okay, so Nathan, go ahead and grab this here. Okay, grab your calculator. In emergency, if you are not using a TI-84 and you're having to use my older TI-83, here is the other way that you should have done this, or you could have done this. We'll rewrite this as 2 to the x is equal to 21 over ln of 2, okay? What you could do is you could take the natural log of both sides.
Or you can just take the normal log.
Oh, that's true. And then you could have a 2 to the x, and what's going to happen is that x kind of comes down, okay? Because the logarithmic rules here at play. Then you have the ln of 21 over ln of 2. I don't know why I wrote it. No, it's the ln of 21 over ln of 2. That's what it is, okay? Well, the first thing I want to do is just, you could do this, or you could just expand it out if you want to just go one step further. You don't have to, but you could do ln of 21 minus ln of 2, because logarithm rule states that if you're taking a logarithm of a fraction, you're essentially just taking the logarithm of the log of the top part of the fraction, and you're subtracting the bottom part of the fraction, the natural log or log of the bottom part of the fraction.
You don't have to
Honestly, I
apply the
think it's
natural
harder.
log to.
Yeah. Okay. Yeah. If you think it's harder, then
Natural log to the second part.
what's up?
Because like the bottom already has natural log, so do you have to do that twice? You have to-
I'm sorry.
So it's like the natural log of 21 divided by the natural log of 2. So you
Well,
apply the
uh-huh.
natural log to 21, would you have to apply the natural log to the natural log of 2?
Yes, because it's like saying that the natural log of 2 is equal to is equal to. I'm sorry. It's like saying that the natural log of 2 is going to be equal to the natural log of 2, but you're almost saying that 2 is equivalent to the natural log of 2. Is that correct? Do you see what I'm saying? The natural log of 2, the value of that is that equivalent to just 2. All right. You're asking the questions. I'm trying to give you the answers, but look where it takes us. It's okay though. Okay.
If you were to do that, you'd have to do natural log twice.
Yes. Well, it's like
You don't
because
write that down.
this gives you a different constant function, right? That is not equal to 2, right? So you have to take the natural log of 2.
When you wrote it, you just wrote natural log 1.
Where? Oh, so here. Which? Oh! I see what you're saying here. Okay. All right. You're right. I see what you're saying. I see now what you're saying. My ear, my voice. Okay. There we are. That's the more accurate way. Thank you, Christina. That was your point. You weren't. Okay, I got you.
You thought it was a question, but it was more like.
It was like, Mr. Wee, look what you wrote. I get it now. Okay. Do you see how much fun Mr. Wee has with natural logs and logarithms? I was just being sarcastic, guys. This is a very frustrating course for me. Okay. All right. So if you plug that into the calculator, you would get 4.92. Okay.
Is there like
2 ways.
specific amount of decimals or less than
Just like to the hundredths or tenths place is fine.
Yeah.
That's fine. Yeah. What time are you here until total?
Fall festival goes to like 2 to 3, so I have the morning.
Okay. All right. I gotta get your. All right, guys. Give me 1 second.
1 second.
Don't be that.
Spotting. I mean, you never know with Tor.
All right. Hold on. Are we finished? The greatest question is:
The point.
are we finished?
Get in again.
What is the point of this point? No.
Find the point. I forgot that part.
All right, Nate. Are we finished with this problem?
So you found the X and now you have to find the Y.
Don't try to trick me.
Wait,
Because we're looking at the coordinate, Danny. We're not looking at just the X point. We're looking at this.
Put it back into the-
So E to
At what point are we looking at? So we have the X point, but we do not have the Y. So Y is just 2X minus 3, and we're going to plug in 2 times 4.92, which you're going to get a decimal answer. So I could totally see this being on the calculator portion of the exam, the final AP exam. Not mine. I'm talking about just the AP exam in the year. I could foresee something like this popping up. Okay, so. And what did you guys end up getting?
Like around 27.29.
Yes, that is correct. So your final answer should be 4.92, 27.29. And that is your final answer. At what point is your derivative equal to 21?
Well, maybe they're in different values.
Okay, so here is your final answer. This is a lot of work. It's just review, but once you're in the middle of doing the work, it won't be so hard, okay? It's just kind of hard to contemplate what's going on.
Sweet. I'll just come back at 9:20 because you're busy and I need to take the month 1 test, so I'll just
Oh, okay.
Back when you're
Okay. All right. Thank you,
all
Taylor.
down.
All right, I appreciate it. Okay. All right. Let's go ahead and move on. Okay. So that is the derivative of ln of x. Should we go over this? What time is it right now? It's 8:49. Yes. Debating if this is. Yes. We do have to do this. Yes. Well, what are we doing? What am I doing here? Okay. All right. Here's another derivative. Now we're taking the derivative. Thank you, Taylor. I appreciate that. The derivative of natural log of x. Oh dear. So we've taken the derivatives of exponents with a base with an exponent variable, but now we're taking logarithms, the natural log, or the derivatives of functions with natural log, or just logarithms. So the derivative of natural log of x is literally just 1 over u times du of dx. This is a very, very easy derivative to remember, I think, out of most of these exponential and logarithmic functions, logarithmic derivatives. Okay, so this is one of the easier ones to do. The derivative with respect to x of ln of u is just simply 1 over u, and if u is derivable or differentiable, then you have to take the chain rule and take the derivative, whatever it was in there. Yes.
Only if that's y, right?
What?
Only if you contain the y.
Only if I contain the y. What do you?
Right? Because like what is it, implicit like something?
Implicit differentiation.
So only if it has y you have the method derivative.
Um,
Do you know what I'm saying? So not yeah.
no, it's not. It's
differentiation.
I
So
know,
no,
but
you
like,
actually don't care about what.
but like never mind. Back to my question.
I think I see what you're saying. You're mixing up implicit differentiation with chain rule, but they're related. Okay, but chain rule is a little bit more broad. So if I had something like this,
Like how will I know when I need to put
just always say this: you always apply the chain rule, no matter what context, implicit differentiation or not. You always apply the chain rule. So in this case here, ln of 4x, right? That would be 1 over 4x, but there is an inside function within that I can differentiate, correct? It's 4x.
Yeah.
So in that way, I have to take the derivative of that guy. So let's call him u. Let's say he's u. I have to multiply it by the derivative of him. Does that make sense?
Yeah.
So with or without implicit differentiation, you still need to do that. If it's like, if we're talking about a context where you need implicit differentiation, you're still applying the chain rule, okay? But either way, chain rule trumps is above implicit differentiation. This has no y, but we still use the chain rule, okay? So that'd be times 4, by the way, okay? That being said, let's see if you guys can do this here. All right, 2 different contexts. Can you find quickly the derivative of both of these situations? The derivative of the function ln of x squared and the derivative of when ln of x is being squared. 2 different things, okay? So please find a place on the whiteboard so I can see where you are right now, okay? So, I mean, you can say I give up, and that's fine. It just lets me know that, all right. That just lets me know, all right, we're having problems understanding this. I need to know where you guys are right now, just so I can get a gauge of like what we need to work on probably the next week or so. The first one is easy. The first one is more straightforward. Don't worry about what's in red. That's the proof. You don't have to write that down, okay? Like that stuff in the red box, don't write that. It's all the stuff in the blue on the bottom right there. Oh, it's... Huh? All right, okay, so you have 1 over x squared, right? And what is the derivative of x squared? Okay, so it should be 1 over x squared times 2x. Oh, because so here, Allie, I'll go to you in just a second, Nathan. Sorry about this. I have to go. I want to go back to Allie. This is a very fun. So because the derivative of ln of u is just 1 over u. Okay, so you want to write that down too. Here. And then Nathaniel, let me check you out.
Oh, she actually did.
Good.
Why? It's not 2 over x. It's x squared. You can't simplify it further. You could. Oh, I see what you did. It's right. It's fine.
Okay.
I see what you did.
How about
We didn't simplify it further. We just left it in the original
like
1 over x squared times 2x. Yeah.
Oh, okay.
And the other one.
Which one is the bigger?
I didn't do the other one.
Oh, okay.
Like who's
Then
doing?
I'll let you do it. And then you can also
U squared. So what is the derivative of u squared? And then the derivative inside is du. So let's see. Let's replace u. U is 2 times x, right? What is the derivative of ln of x?
Like ln is also in the square. So
And then if you want to keep going chain
it would be chain rule. So 2 natural log x times 1 over x.
Do you see where
So, when we place this, we can decide that.
yeah,
Basically, we're switching what's on the
My
inside
God.
and what's on the outside.
that's the first one. That's good.
Basically,
is that it?
Yeah, that's it. Or I mean, if you want to simplify, you can do. Yep.
That's it.
Yep. You can leave it like that, and then the second one is where it gets. The second one is almost saying the same thing. It looks like it's saying the same thing. Identify your u first. Okay.
No one's really just telling that.
So you have. Oh, so you do the derivative of u first. Is that what you do? Oh, so what I was gonna say is this is u. Then we take the derivative of the bigger guy. So you see how it's I replace this as u. I mean this u. So I wrote him as u squared. The derivative of u squared is t times u. So let's go. ln of x. There's a big function and a small function.
So the first thing that you have to get.
So I don't even do the inner guy first. I do that out first. So it's just who is your u? It's the whole thing is so it's u squared. What is the derivative of u squared?
That's the derivative of the inside part.
But is u itself a differentiable guy?
That's more.
Can you take the derivative of u? So you're sure you
Why
can
is
take
it-
the derivative of
That's the derivative of natural log.
yeah.
Okay.
Use and multiply, so you can do.
Yes. So now you do 2u times the derivative of the inside guy.
I'm writing upside down. Yeah.
Right there.
It's mostly
So I know the u is
The what?
That's what happened.
that outside.
Let's replace now what we want.
You memorized it?
No.
So 2 times
I think that's why you not trained within
times
no.
what is the derivative?
You, but you're just defining it, yeah. And this
I love this
is very simple. It's just natural log u.
Oh, yeah.
It's weird that it has
Oh,
two
yeah.
A's.
The derivative
I
of
know
the
that
over
the element of that should be u, and then you square that.
Oh, okay.
So it's just whatever's more.
But is this inside?
This is not.
Yes, it is.
So I know u is really I think like we're so far
I
behind.
realized it after you were supposed to. So this is almost correct.
But
Yes, that's absolutely right. So what I think what you ended up doing was you took the derivative of this guy first, and then you took the derivative of
I said
One
no.
over equations 1 over u, I already defined the u.
it makes it
so 1 over
easier
x
because
squared.
you keep going.
That's why I called it.
This works too.
Oh, so one over you, that's the derivative.
derivative of u.
So ln of, so I know it's gonna be
right, 2x.
ln of x, the derivative of that.
Just say purple.
This one is more complicated.
In a more general sense, if you took ln and let's say the base of x was some guy that you have to differentiate farther, then you do you
This
just
is
have to
notation that
consider that
refers to the
this guy
derivative of u with respect to x. So the derivative of this guy with respect to x.
The only problem is here,
With respect to x.
u is no longer whatever's in ln of x. Also, it's
not two numbers.
actually ln of x
So
itself,
this is just if I find division, it's just
because when you look at it, it's squared. So the thing is, you have to define this. That's all u is. It's never consistent. It always hops around what u is. So that's what you're trying to do.
Sure.
And I like this.
Is it your bird?
I don't know if that's wrong. I always have complicated issues.
Oh, really?
It's just you have to define
Remember back in the day, like,
big functions.
So I thought there I wanted to do
So this is this, right?
So this one I'm less there.
So this is this, right?
Yeah, because when you
This is this.
no, no. So
Basically,
I know this is a secret right now because
outside.
it's just this, right? Okay, so let's stay with this, right?
So this is the first side, the opposite, right? The outside is the zero.
So don't worry about what I said. Just look at this.
So just ignore the outside. Right, square, then you want power, right, which is 2x.
And what is it?
We're gonna keep the x the same, so then afterwards, y.
Yeah, so
that's almost, because that side stays the same.
But
So the
now
other side-
that's you did the chain reaction, right? But what is
And then
this?
How would you get?
the other one.
Now this is only this is now.
Which is just using that expression.
So now you have to consider that this is here. So that's it's fine. You this contact you actually know x. So now it's squared. You have to take the derivative of this stuff. So if it was just ln of u, yeah, you do this, right?
Oh, wait, I forgot to, like, so
But
basically.
now
all these
ln
questions is like taking the chain on the same.
you can go ln it's so what ln of u.
This is one chain, and then this part of this.
So now we don't even have to solve it. Would it help if I call this?
That's also my.
Okay. So it's gonna be
The
a
new u
it's gonna be
be.
sorry.
It's
It's gonna take a little bit of time.
I did it. Was it? I think it was mystery and mystery,
You're not keeping.
or just mystery.
This jump.
Oh yeah. Mystery.
We understand. This is where I wasn't counting so long. Okay. All right, guys. Let's see what time it is. It's 9:01. Good. Okay. So hopefully this is what you ended up getting. You ended up getting 2 over x for the left hand scenario, and the right hand, I believe it should have been 2 ln x over x. Yes. Okay. Very good. I don't know if I should give you another one. No, I'll move on to the last topic. Okay. Did you want to see that again, that solution, or no? No? So again, I know it's confusing because here it says u here and u here, but then over here I changed my u up. Okay, so if you have problems with that convention, come and see me. Okay, this is probably the part where most seniors or most students in calculus get lost in u substitution in derivatives. Okay, it's much easier than it seems, but the convention, it almost seems like it's hopping around what u is. Okay. It's just a tool, and that's the best way I could describe it. For me to kind of go in depth and really tutor it, okay, all the way through until like it starts to kind of organize and make sense in your head. Please come and see me in order to do that, right? For the purposes of this class, though, in the hour and 15 minutes that we have, I need to get through as much content as I can for all of you guys, okay? So my next and my last point is the derivative of log base a to the x. More generally, okay, it's not just natural log, it's log base of any other base besides e, okay? That's what it's going to look like. That's the derivative. If you want the proof, it's in red. You don't have to know the proof, but you can write the proof, all right? It's essentially a formula, but the thought process behind the proof might help you to figure out the derivative of any other log-based function. When you're trying to find a derivative of a log-based function, if you know how to do the proof, you can apply it. If you forget what the formula is, you can essentially figure it out knowing a few logarithmic rules. I do think either way has its merits, though I am going to be honest in saying that I was better off just memorizing it, as besides to just knowing the proof inside out. But to those that remember the proof inside out, they can recall the formula just from kind of proving it to themselves. Okay. So again, if you just want to boil it down to exactly what you need, okay, no filler in your brains and like trying to just pass this exam, this top portion is all you need. Okay. If you want to actually understand the subject and where this comes from, okay, then you want to understand where the proof where the proof for this comes from. Because you can apply the steps to the proof to figuring out the derivative of a log-based function. And don't worry about the green either. I'm sorry. So the green is just a lot of extra. If you're doing the red, then I suggest you do the green. Okay? If you're doing the red, I suggest you do the green. Otherwise, if you just want to know exactly what you need to know, just for memorization's sake, rote memorization, right? At the cost of losing a little bit of the integrity of learning the content itself, then this is all you need. But if you want to know a little bit of the theory behind it, it would benefit to write what's red and green, okay? All right, so, and for this class time that I have, I'm going to give you this. I'm going to give you two more examples to work with, okay? Please find the derivative of log base 4x squared with this formula here, okay? Please find the derivative for this right-hand function right here on my right hand, this one right here with the controller, all right? Find the function, or find the derivative function for that. Log based 4. That's absolutely correct. Yes.
What is A? A is natural log of 4.
So weird. Yeah, okay. So then you can cancel the 2 and that. So right. No.
Just one of the X.
So first, identify what your A is. What is your A?
4.
X.
I'm sorry. What your A?
Log base 4 x squared.
Yes.
Log base 4 x squared. See, you're blind. I'm Asian. You're blind.
I don't know, Nate.
Wait,
So A isn't just X. Does that make sense?
So
All right, there we are.
would be log.
Is
It
it
would be
minus
x
1
squared
over
plus
X
x.
Because is it U?
Yes, it is. Danny,
U
it
is
is.
X squared?
U is X squared. A is 4. That's correct.
So I did.
Yes. So you have.
A is just.
Did you?
Is it 2 divided by X times natural log 4?
No. I'm just kidding. Yes, it is. It is. It is. Sorry about that. You're like, wait a minute, Mr. Wade. I'm about to destroy you. Okay. This is not funny. Okay.
2x over x squared ln 4.
Oh, that's okay. So that's ln of 4, right? I thought you said ln of y for a second.
Colleges give you
Oh, that's
text
plus
messages.
4.
Got it. Yeah, there you are. Oh, yes. Can you simplify that?
Yeah, so you take out the square. I'm not going to.
That's right. So it's just gonna be.
Final answer, just 2x 2 over x ln 4?
Can't you do the
Because
cross out the 4 and the 2?
You cannot. Yeah. Because the natural log of 4, if you put in your calculator, is not equivalent to just 2. You see what I'm saying?
So do we find the natural log of 4 or just leave it like that?
You can leave it like this. Yeah.
Are you coming today?
well, it's kind of
That's good. Okay. All right.
Would that be the reduced form?
Huh? Yes, that would be the reduced form. Good job. Good job. All right, one more problem, guys. So I apologize. There's a lot of memorization for this part, okay? But we're going a little bit more functional here, okay? A little bit less time for the theory, and a little bit more functional here. What if I gave you this? How about the ln of x? Oh, I don't like it, Mr. Wee, okay?
Sure.
Good. Okay, so,
Wow.
all right, fair enough. Huh? This is going one step back. This is not what we just learned. This is the thing before, the thing that most of you do not like. I will give you again the formula for this one. This is again, if you need to know, I'll write in blue. Let me see. It's if,
So it's just
Just
x
1 over
natural
x
log
natural.
Yep. Okay. I'm sorry. I'm sorry I called you a jerk. That's actually very easy.
right. Okay, if you remember, there you are. It's going back to the problem beforehand, like the subtopic beforehand, on how to find the derivative of natural log functions. The general rule is in blue. What would the final answer look like in the part that's green? Okay, the part that's green.
No, it's not.
Yeah. So you guys already got this?
Are you asking what the answer is?
Yeah.
Or
Yeah, I am. Yeah, I'm sorry. I'm asking you what the answer is, guys.
1 divided by x times natural log of x.
Yeah. Wow, you guys picked it up quick. Hey, what about you guys in the back? Did you guys get this so far?
Let me actually do it.
Okay. Fair enough. All right. All right. Tables here. Are you guys good with this? What is the answer for this problem here? I know my writing is not
I just have really bad eyesight.
okay.
Where's the problem?
Times natural log of x.
Okay. The function is y is equal to ln of x. Find the derivative of this function. And then if you need to know what we're looking at the derivative of logarithmic functions. So the derivative of natural log of u is equal to 1 over u times du dx. Do you want me to walk you through this one? Okay. Okay, so let's go ahead and walk you through this. So what you have is this. Okay, so we know that the derivative of ln of... Okay, so maybe this will help out, right? I'm not even going to say u anymore. I'm going to say the natural log of whatever is in here, okay? The derivative of the natural log of whatever is this. The natural, or it's 1 over whatever that it's in there, and you have to take the derivative of whatever that was, right? Not you. Let's try to go away from you, okay? Does that make sense? Okay, in this case, who is the blob, or what is in place of this blob? The ln, the whole thing, the ln of x, right? So that's gonna be ln. I'm sorry. So dy over. I'm sorry. So dy is the derivative of this function with respect to x. Okay. It's going to be what? What is 1, or what are we going to put under 1? Yes. Okay. But now I got to figure out so that's essentially equal to 1 over the blob right there, right? But don't forget, there's a chain rule. I still have to take the derivative of that blob with respect to x. What is the derivative of this blob? ln of x. Is it over Because what is the derivative of ln of x? Okay, to make it simpler, if I could rewrite this, the ln of just the derivative of ln of x is just equal to 1 over x.
What? Wait, didn't we define it as u or blob, whatever?
The blob is you.
Oh my god.
It's okay. So I think the way I taught it was still a little bit confusing. So this should have been your final answer, I believe. Yes. So this should have been your final answer. It should have been 1. 1 is equal to ln of x times x, or it could be 1 over x times ln of x. I think. Okay.
U is just a phrase. Oh, use land back. Oh, I got you.
You is the same as the
U isn't an actual variable.
Finally, we
It's
got
a
another
substitute.
one.
I gotta refrain from using the blob thing because you guys are gonna be classical mathematicians saying about it's derivative of the blob with respect to x, professor. Okay, duh. Okay, what? All right, guys, that's the end of class. I'm sorry. All right, I will try my best to teach this better next year, and I'll try to help you guys out. All right, you guys have a